Today we'll discuss about thermodynamics in real gas, which is part 1. Our topic for discussion is ideal and real gas application, then density of gas, then what are the standard conditions, NTP and STPs, and various flow units. Ideal gas of equation of state is P into V is equal to N into R into T. So, but N is number of moles, we can write mass of the gas upon the molecular weight of the gas. So we can write P into V is equal to M upon small m upon capital M into R into T, where P is the pressure in Pascal, absolute, V is the volume in cubic meter, N is number of moles, mass upon molecular weight in constant. A small m is mass of gas in kg, capital M is molecular weight of gas in kg per kilomole. R is universal gas constant, which is 8314.5 joule per kilomole per Kelvin, and T is a temperature in degree Kelvin. Now, real gas equation of state. Now, P into V is equal to Z into N into R into T, where again N is number of moles. We can write P into V is equal to Z into a small m upon capital M into R into T, where Z is the compressibility factor. So what is this? Compressibility factor takes care of volume change due to change in pressure and or temperature. Normally, compressibility factor increases with increase of temperature at constant pressure and vice versa. Similarly, compressibility factor decreases with increase of pressure at constant temperature and vice versa. And this is used for real gas application. So what are these? P is again Pascal absolute, V is the volume in meter cubic meter, Z is compressibility factor of gas in constant, N is number of moles, which is a small m upon capital M in constant, M is mass of gas in kg, capital M is molecular weight of gas in kg per kilomole, R is universal gas constant, which is 8314.5 joule per kilomole per Kelvin, and T is temperature in degree Kelvin. Now, if you want to find out the density of the gas, of course, real gas, then P into V is equal to Z into a small m upon capital M into R into T. So, density is derived from the above real gas equation, which is density is RD, which is denoted as RD, is equal to mass upon volume. So, a small m upon V. So, we can write RD is equal to P into M upon bracket start Z into R into T bracket close, where RD is density in kg per meter cube, P is Pascal in unit absolute, M is molecular weight of gas in kg per kilomole, Z is compressibility factor of gas in constant, R is universal gas constant, which is 8314.5 joule per kilomole per Kelvin, and T is a temperature in degree Kelvin. So let us understand with an example. Nitrogen gas having pressure of 1.5 bar gauge and temperature of 30 degrees Celsius. Calculate the density of gas assuming compressibility factor Z is 1. So how we can calculate? Pressure is P is 1.5, adding 1.013 is becomes 2.513 10 to the power 5 Pascal. Temperature T is 330 degrees Celsius, which is 30 plus 273.15, which is 303.15 degree Kelvin. Molecular weight of nitrogen M is 28. Compressibility factor Z is 1, it is given. So universal gas constant R is 8314.5. Density of nitrogen RD is P into M upon Z into R into T. So after putting all the value, density of nitrogen is coming to 2.79 kg per meter cubic. Now, what is NTP and STP? NTP stands for normal temperature and pressure, and it is condition of gas when pressure is 1.01325 bar absolute and temperature is 0 degrees Celsius. Normally, pressure 1.013 bar absolute is generally acceptable value. Similarly, a standard temperature and pressure STP, it is condition of gas when pressure is 1.01325 bar absolute and temperature is 15.5 degrees Celsius. So pressure of 1.013 bar absolute is generally accepted value. So this is NTP and this is STP. Now various flow units, mass flow rate. Mass flow rate through any equipment or piping remains constant. It does not depend on any operating parameter like pressure and temperature, and it is generally expressed as kg per hour, kg per second, ton per hour, etc. Normal volumetric flow rate, it is actual volume of gas at normal temperature and pressure. NTP condition means pressure is 1.01325 bar absolute and temperature is 0 degrees Celsius. It is expressed as normal meter cube per hour. A standard volumetric flow rate, it is actual volume of gas at a standard temperature and pressure, which is called STP condition, means pressure is 1.01325 bar absolute and temperature is 15.5 degrees Celsius. It is expressed as S cubic meter per hour or SCFM, etc. Actual volumetric flow rate, it is actual volume of gas at operating temperature and pressure. Condition means actual pressure and actual temperature. It is expressed as meter cube per hour, feet cube per minute, etc. So we can see mass flow rate doesn't depend on pressure and temperature. Normal volumetric flow rate pressure should be 1.013 bar absolute, temperature 0 degree. A standard volumetric flow pressure is 1.013 bar, temperature is 15.5 degrees Celsius, and actual flow volumetric flow rate, it is based on actual operating pressure and temperature. So now what is the relation between the flow and density? Density of gas can be calculated at NTP, STP and or any operating condition. Volume flow is calculated once density is known. Normal volumetric flow rate is equal to mass flow rate upon density at NTP. Similarly, standard volumetric flow rate is equal to mass flow rate upon density at STP. Actual volumetric flow rate is equal to mass flow rate upon density at operating condition. So if volumetric flow rate is given, then convert flow rate into mass flow rate and then divide the respective density to calculate volumetric flow rate at other condition. For example, if normal flow rate is given, then multiply the normal flow rate with density at NTP to calculate mass flow rate, then divide mass flow rate with the standard density to convert a standard volumetric flow rate, or if you want actual flow rate, then divide the mass flow rate with operating density. So thank you.